Alright, so in 5.3 day 2, we're going to look at phase shifts with your sine and your cosine. So we're going to call this trig graphs with phase shifts. Okay, so what is a phase shift? It is a horizontal shift for a periodic function. Okay, so that means it's either going to go left or it's going to go right. What part of the graph does the phase shift affect? So because it's horizontal, it affects the x-axis. So it's going to be affecting the x values in our chart. Okay, and I have up on the board your key values for sine and cosine. So we're going to be using those today to create our table. Okay? So we're going to look at our functions here. You have y equals a, the sine of k, x minus b. And you have y equals a, the cosine of k minus b, where the k is still positive. Now there are some similarities here, so you can see the amplitude is the same. It's in the same position in front of your function. Okay, the period is still found by doing 2 pi divided by k. And look and see where this k value is. Okay, it's still inside the trig function, but because you have a phase shift, it should be outside of the parentheses. And then your phase shift value is called b. Okay, and in both of your equations, it's x minus your value of b. Okay, and then you still want a positive k value. So one thing you were asked to explain in your review packet is when does the graph move left, when does it move right? So your b value, if it is positive, it goes to the right. Okay, so if it's positive, it shifts right on the x-axis. But when you look at it in the equation, okay, if your b value is positive, what you see is x minus b. So some people, when they were explaining it, they were saying the b value is negative and it goes to the right. Okay, if your b value is positive, and that's why it's going to the right, it's your equation that has the opposite in there. So when you look at it in the equation, the negative is in front of it. And when your b value is negative, that is when it shifts to the left. Okay, and then of course when you see that in the function, because you're doing x minus a negative value, you only see the simplified version, which is the x plus b. Okay, so you see the simplified version, but it comes from subtracting the negative. So you're going to have to pay attention to your value of b so that you can graph an appropriate interval, and this is going to be the interval that we are highlighting. So, and it says an appropriate interval on which to graph one complete period is, okay, so it says it goes from b, okay, and b is going to be your phase shift, and then b plus 2 pi over k. Okay, so that is your phase shift plus the period of that function. Okay, so we're going to be finding this interval today. That's what we're going to be boxing in with our highlighter. Okay, and then I asked you to observe in the formula above where the value of k is. And what would you have to do if there was a coefficient of x that was not 1 in order to get the proper k value in the phase shift? So if there was a coefficient of x that wasn't 1, okay, then you need to factor out that value. Okay, so if the coefficient is not 1, okay, you are going to have to factor out that k value. Okay, so it might look something like this. If you have the sign of k times x minus b, we need that to be factored out. And we'll fill this part in a second of what that would be. Okay, so we need to factor that part out. So for the next one, we are just going to be finding the phase shift of these functions. Okay, so for part A, we have y equals 3 sine of 4 x minus pi over 2. And B, we have f of x equals 3 sine of 4x plus pi over 2. Right, so in this one, the coefficient of x is 1, and this one it is 4. So if the coefficient is 1, then you can find your value right away. Okay, to find the phase shift value, you can just set x minus pi over 2 equal to 0. Okay, and then x would equal pi over 2. That is your value of b. Obviously, when you are doing this, you're going to recognize the pattern. So you can just jump to b is positive pi over 2. And what that means in terms of the phase shift is you go pi over 2 units right. Okay, now if the coefficient is not equal to 1, then we are going to factor that out. So when you factor out the 4, you're going to have x plus. I want you to think about how you find that value. So when you factor it out, what are you doing? Okay, so let's find that value that goes in there, and then can you guys tell me how you find it? Especially if you have it written down how to do it. Yeah, just divide by 4. Good. Okay, so when you're factoring something out, you're just dividing. So you're going to divide pi over 2 by 4. Yep. Okay, and when you divide by 4, it's the same thing as multiplying by a 4th. So you should get pi over 8. Okay, and some of you might have just been thinking, oh, 4 times pi over 8 reduces to pi over 2. That's fine too. Okay, so then your value of b, because you have the plus here, is negative pi over 8. And your phase shift is going to be pi over 8 units left. All right, so you guys give this one a try. G of x equals the cosine of 1/2 x plus pi over 6. Let's try quickly. You want to think about the next step, you can. Okay, and then your setup is going to start the same way. So it's x plus, and then you are dividing pi over 6 by 1/2, which means you're multiplying pi over 6 by the reciprocal. 2 pi over 6 reduces to pi over 3. Okay, so then your value for b is negative pi over 3, and your phase shift would be pi over 3 units left. Okay, so if you have a phase shift, an easy scale to use on your x-axis is the phase shift value. You don't have to use that. Sometimes it's better to use like half of your phase shift, but you guys will kind of play around with that and see what works best for you. Okay, sometimes that will match if you do the period and divide by 4. Okay, so on our graphs today, we are going to have phase shifts, but those are going to be combined with some of the other vertical transformations we looked at yesterday. So sometimes there's a vertical shift up, sometimes there's a stretch. Okay, so there's going to be multiple things happening here. All right, so for all of these, you're going to find the amplitude, period, and the phase shift value. Okay, and then we're going to graph. Just like yesterday, we're boxing in one period and we are spanning the grid. And of course, I will give you the gift of grids again today. Okay, for your practice. All right, so for A, we have y equals 3 cosine of x plus pi over 4. Okay, so the first few things I like to pick out from here are the amplitude and the k value. The amplitude is always multiplied in front, so it's 3. Okay, your k value is in front of your x, and in this case, it's going to be 1. Okay, you can also think of it as in front of your parentheses now. So if your k value is 1, what does your period have to be? 2 pi. Okay, now the phase shift, we're going to write the value for b, and then we're also going to write what that does. It is set up this way when you do your quiz, like you'll have to say what b is equal to. So your b is negative pi over 4, and that means you're going pi over 4 units left. Okay, so before we do our scale, we are going to calculate what one period is, okay, using that formula that we talked about on the front. I also have it on the board up here. It's b to b plus that period. Okay, so if your b value is negative pi over 4, and then you have negative pi over 4 plus 2 pi. Okay, and that we are going to simplify. Okay, so it's always b and then b plus the period. Okay, so we have negative pi over 4. Do you guys know what 2 pi minus pi over 4 is? 7 pi over 4. Sometimes you guys can visualize it on the unit circle if it's 2 pi. If not, you can always get a common denominator, right? You can put this under 1 times 4 times 4. So it's 8 pi over 4 minus pi over 4 to get 7 pi over 4. So this is what we are going to highlight on our graph, okay? Now, when you are doing your table, there are so many different ways to do your table. There are many ways that you can get these values. For one like this, where your period is 2 pi, you can use the original function and you can just subtract pi over 4 for each one. Okay, so your start is negative pi over 4. Your end is 7 pi over 4. Okay, so now instead of starting at the intercept, well, we're still starting at an x. Well, we're starting at the max for this one. You're always starting at your phase shift, and then you're always going to end at the period value. Okay, so a good scale to go by here is pi over 4. So I'm going to make each one pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7, 6, 7. And then 8 pi over 4 is 2 pi. Okay, so because this is cosine, you're going to start at your maximum and you're going to end at your maximum. So your maximum is 3 because your amplitude is 3 and there's no vertical shift. Okay, so if you start at 3, you're going to end at 3. Your halfway point is negative 3. Now, because, like I said, because this one has that same period as your cosine of x, the cosine period is your 2 pi, you really can just subtract pi over 4 from each one to find your new value, right? And we already did that with the 2 pi minus pi over 4, the 0 minus pi over 4. Okay, that is not going to work every single time because this has to happen halfway in between. It does work for this one, so you can use that. This is the 3 pi over 4. Or something that you can always do is when you start at negative pi over 4 and you're at 3, 1, 2, 3, okay, you end at 7 pi over 4 and you're at 1, 2, 3, you can just count your units and find the halfway point. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units across. So 1, 2, 3, 4 units is 3 pi over 4, and that's going to be at negative 3. And then you can find the halfway mark between those two. Okay, so halfway in between 1, 2, 3, 4 is going to be 1, 2, and that's at pi over 4. So at pi over 4, you're at 0, and at 5 pi over 4, you are at 0. Remember, we're connecting these with a curve. This is what we'll box in, and then we're going to continue that pattern. So 1, 2 to the max, so we'll go 1, 2 to your intercept, 1, 2 to your intercept. Okay, and then when you box in one period, I just want you to highlight it like this. so that we can still see your graph. Okay, so you're going to scan the grid, you'll have your table of values, and then you'll box in one period there. Okay, so for B, let's start with the amplitude and the period. See if you guys can find those two, and then you can start thinking about the phase shift. Okay, so what is our amplitude? Amplitude is always outside the function. So if you don't see anything, it's 1. Okay, the period, so your A value is 1, your K value is 3. Okay, so your period is 2 pi over 3. And then to find the phase shift, we have to do what we did earlier when you factor out the 3. So your phase shift is not negative pi over 2. You have to factor out the 3 so you can find that value. Remember that when you are dividing something by 3, if it's a fraction, you're just multiplying it by 1/3. So pi over 2 times 1/3 is pi over 6, right? And then because you have a plus, this is going to be negative pi over 6. Okay, and so what that means is we're going pi over 6 to the left. Okay, and then we always want to find what our 1 period is. I'm going to write that work here, and then I'm just going to put my table over here so I have more room. Okay, so the 1 period starts at your B value, negative pi over 6. And then we're going to do the phase shift. What did I say? Yeah, your B value. Okay, so it starts at your B value and then B plus the 2 pi over 3. Okay, so can you guys calculate the period in which we're going to highlight? And then from there you can start your table. Okay, and you can always get a common denominator, so times 2 times 2. Okay, so this would be 4 pi minus pi here. So you'd have 3 pi over 6. And what is 3 pi over 6 reduced to? Pi over 2. Okay, so again, this is what we're going to highlight. All right, so when you're doing your chart, okay, we're going to start at our phase shift value, negative pi over 6. We're going to end at pi over 2. And this is cosine. So for cosine, we start at the max, we end at the max. So look at your amplitude and then look to see if you have any vertical shifts. This plus 1 is going to move everything up 1 unit. So what's my max going to be? My max value? 2. Okay, so 1 plus 1 is going to be 2. We're going to start at 2. We're going to end at 2. Okay, and then if your amplitude is 1, normally the min would be negative 1. But if we shift that up 1, where are we? At 0. Okay, so midway we're going to be 0. And what's halfway in between 0 and 2? 1. So we're going to be at 1 here and here. Okay, this is going to be our mid. Okay, so we'll go by pi over 6 because that's your phase shift. So for this one, I can't just do like by pi minus this because my period is different. So that changes things. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6. And just label a few. Okay, and if your scale is 1 on the y's, it's okay if you don't label it if your scale is 1. Okay? But if you do change your scale, make sure you make that visible. Okay, so for this one, I'm going to start at negative pi over 6, and I'm going to go to my maximum 2. I'm going to end at pi over 2, which is my maximum. So again, to find the halfway, I just have to count the units. This is 1, 2, 3, 4 units. So at 1, 2 is where I'm going to reach my minimum. So my halfway is pi over 6. All right, and then we're going to find halfway in between those. So halfway in between here, I'm at 0. Halfway in between these two, if this is 1 pi over 6, this is 2 pi over 6, which reduces to pi over 3. Yay. Okay, and then remember this is going to be what we're highlighting. And then we're just going to span that grid. Okay, so 1 to the middle, 1 to the min, 1 to the middle, 1 to the max, middle, min. And negative pi over 6 to pi over 2. Okay, so what questions do we have on that one? I combined several things together. Alright, let's try this one. Y equals the sine of 3x plus 5. Okay, so your amplitude is always multiplied in front, so this is 1, your k value is 3. So your amplitude is 1, your period is 2 pi over 3, just like last time. Okay, so let's look at our phase shift. So if the 3 is inside, identify what your phase shift is going to be. And then let's see if we can calculate the 1 period. Okay, so if you do pi divided by 3, you just get pi over 3. Okay, and then because it's a plus, your b value is negative. Okay, and I do see that I made all your b values negative today. You are going to get some positive ones. Okay, and when that happens, you are just going to add them. So you are going pi over 3 to the left in this case. Okay, so your 1 period is negative pi over 3. and then negative pi over 3 plus 2 pi over 3. Okay, so if you're going from negative pi over 3 to pi over 3, there's going to be things happening in between those. And this is going to be a little bit easier to figure out just mentally because negative pi over 3 to pi over 3, halfway in between those is going to be 0. What's halfway between 0 and pi over 3? Pi over 6. So halfway in between these two would be negative pi over 6. So a good scale for your graph would be to go by pi over 6 or just make every other one pi over 3. So this would be 1 pi over 3. This would be 2 pi over 3. 3 pi over 3. Okay, so if your phase shift is a little bit larger, like pi over 3 or pi, okay, or pi over 2, then it's better to go every other one instead of every mark. It'll just be easier for you to graph. Okay, but there might be some where you have to find an in-between spot. So this is sine. So at sine, we start at 0, we end at 0. There's no vertical shifts happening. My amplitude is 1, so this is going to be 1 and negative 1. Okay, so at negative pi over 3, I'm at 0. At pi over 3, I'm at 0. Halfway, I'm at 0. And then this might be one where I want to label this as 1 and this is negative 1, just because I do think it's a little bit easier to graph. You don't have to do that, okay? And you are going to box in your 1 period. All right, so one of the questions I got on the exit slips was, how can we apply these to some real world situations? So we're going to talk about one today, and then there'll be a few more in chapter 5. Okay, so this one's about blood pressure. Each time your heart beats, your blood pressure increases and then decreases as the heart rests in between those beats. And the maximum and minimum blood pressures are called the systolic and diastolic pressures. Your blood pressure reading is written as the systolic over the diastolic, and a reading of 120 over 80 is considered normal. A certain person's blood pressure is modeled by this function. P of t equals 115 plus 25 sine of 160 pi t. And it says your P of t is going to be the pressure in mmHg. That stands for millimeters of mercury. And T is going to be the time in minutes. Okay, we're going to need to know that to interpret parts A and B. So in part 1, it's asking us to find the period. And then in part B, it says to find the number of heartbeats per minute. Okay, so part A is just the same as if we were finding it from an equation. So we're going to use our formula, the period equals 2 pi over k. I want you guys to plug in the k value for this equation p of t and simplify. And start to think about what that means. Okay, so what was your k value? Yep, 160 pi. So the pi's are going to cancel, and 2 over 160 is 1 over 80. Okay, that is going to be the period. And then what this means is this is 1/80th of a minute. Okay, so you have 1 heartbeat in 1/80th of a minute. So when you're trying to find the number of heartbeats per minute, we're going to use that to help us. Okay, so since there is 1 beat, because this is 1 cycle, that's what your period is, the 1 cycle. So there is 1 beat in 1/80th of a minute. There are how many heartbeats in 1 minute? So if there's 1 in 1/80th, how many are there in 80? Okay, so then the way that we would write that is we would just say 80 BPM, which stands for beats per minute. Okay, so you will have a couple of application problems. On your homework today. Okay, so your homework problems are 30, 33 through 37, 77 and 78. There's no part C. And I'm going to give you this sheet, and then I'm also going to put up the book for you.